Okay, so far in the last video, we have studied the conversion of the units of the gas, right? And we studied the manometer, barometer, how we measure the gas, and how we convert the unit of the gas from one unit to other unit or from SI unit to the some non-standard units. Okay, so now let's go further. So let's start from the gas law. So, right, okay, last time we have studied that the gas law means the function of volume, temperature, okay, pressure, and the number of the moles. That is the gas law, right? Gas law is the law that defines this function of the four variables: volume, temperature, pressure, and the number of moles, right? That function is said to be the gas law. So now let's start from very preliminary gap. That's the Boyle's law. Okay, what the Boyle's law say? This is given. This law is given by Boyle. Okay, so what his law says that volume is directly proportional to the inversely proportional to the pressure when temperature. Let's see that we have a four variable, one, two, three, four. So Boyle's law tells about volume and temperature, and these two are constant. Okay, and so volume and pressure, sorry. So okay, so Boyle's law tells about the gas law is the T is equals to function of um, volume, temperature, pressure, and the mole, right? So the Boyle's law tells about this function. It describes this function, and that Boyle's law is equals to the law is equals to f of volume and the pressure, and the temperature and the this number of mole is constant. So when the temperature is fixed, you are not changing the temperature, and the subject matter, the number of the gas molecules are also fixed, you are not adding further, then volume of that gas is inversely proportional to the pressure. Okay, so volume of the gas is inversely proportional to the pressure, and if you do little bit math here, then you can find that volume is equals to k some constant times p, or k by p, or you have a volume is equals to pressure times volume is equals to constant. So this is the Boyle's law, right? You just say crisscross pressure times the volume is equals to, you remove the proportionality constant, that is the constant. So when pressure increases, volume decreases, and the pressure decreases, volume increases. This says the Boyle's law. But provided that this is not true if these two are not constant, if temperature and the number of moles should be constant. If these two are constant, then pressure and volume has the inverse relation. More pressure, less volume. Less pressure, more volume. That's fine, right? More pressure, it will squeeze, and less pressure, it will expand. So, but the temperature and the number of moles, the fixed. So look at that. Volume here in the y-axis, in the x-axis pressure. As the pressure increase here, 1000 torr, 2000 torr, 3000 torr, right? Pressure increases here, but the volume get decreasing. See, volume get decreasing. So, and the volume versus 1 by P is linear. So remember that the Boyle's law is a linear relation again. Again, the linear relation, because we are studying the gas law, the ideal gas. So we are assuming all these gas are ideal. That's why you see that volume and the pressure is a linear here. So this is a linear relation. Okay. So now Charles' law, there is another law which is Charles' law. What the Charles' law say that the let me recall you the Boyle's law. Boyle's law say that what pressure, volume, temperature, number of moles, right? These two relation, these two are constant for Charles' law. But now the Boyle's law, sorry, but the for the Charles' law, this is just opposite. Pressure, volume, temperature, number of mole. For the Charles' law, these two are constant. Pressure and the number of moles are constant. Volume and temperature relation is the Charles law, and that is said to be the volume is directly proportional to temperature. It means that volume increases, temperature increases, volume increases, and vice versa. Temperature decreases, volume also decreases. Okay, temperature decreases, volume also decreases. So that is the Charles law. But this is only true if pressure and the number of moles are fixed. So that's why Charles law is a function of pressure, volume, and the temperature, uh, and pressure and the number of moles are constant. So there are other laws also. Okay. So for example, one the Gay-Lussac law. So that Gay-Lussac law tells us that now let me recall that pressure, volume, temperature, number of mole, right? So temperature and the number of moles are constant for Boyle's law. Pressure is uh, the volume is inversely proportional to pressure, right? And then Charles law, pressure, volume, temperature, number of mole, and the so if you go back to the Charles law, so look at the number of mole and the pressure is constant. Number of mole and pressure is constant. Number of mole and pressure is constant. Then this tells that volume is directly proportional to T. That's the Charles law. So what Gay-Lussac law? Look at that. We have two things. We have four out of four. We have temperature, no, number of mole constant, pressure and the number of mole constant. Now let's say volume and the number of mole constant. Okay, that's the other law comes from volume and the number of, because the number of mole should be always constant. Okay, so pressure, volume, temperature, number of mole. Number of mole constant, okay, and the number of mole constant, and let's see that number of mole constant and the time temperature constant, that constant, Boyle's law, BL, and again PVTN, okay, uh, pressure constant, number of mole constant, that is Charles law. And a Gay-Lussac law, what remain? And a PVTN, and a Gay-Lussac law says that volume and the number of mole are constant. Then what happens? Pressure is directly proportional to temperature. If volume and the number of moles are constant, then what's remaining? Remaining, let's take me down the color for the remaining. Okay, so the remaining is this, right? So remaining is this. So volume and number constant, these two have the relation, right? And the temperature and the number of mole constant, these two have the relation. Okay, now volume and the number of mole constant means pressure and temperature have the relation, and that is pressure is directly proportional to temperature. Pressure increases, so okay, temperature increases implies pressure increases, and the temperature decreases implies pressure decreases, like that. Okay, so now these are the laws, and now let us combine these laws. Okay, so and this after combining, we will have one very good law after combining. So let's see, let's combine Boyle's law and Charles' law. So look at that. Boyle's law is B is inversely proportional to 1 by P. Charles' law is B is directly proportional to T. So you can combine these two. It means that V is directly proportional to 1 by P times T. So if you remove the proportionality constant, V is equals to constant times T by P. So now uh, T by P, sorry, T by P. So if you crisscross that, and you will get that V times P, PV is equals to constant T, constant T, or PV by T is equals to constant. That is also second way of saying. Okay. Now, finally, we have the Avogadro law. So Avogadro law, look at that. Pressure, volume, temperature, number of mole, right? And pressure, volume, temperature, number of mole. Pressure, volume, temperature, number of mole. Pressure, volume, temperature, number of mole. Okay. So we have these laws, and let's make them one by one constant. Okay. So temperature and this is a Boyle's law, these two constant. Okay, and the number of mole and the volume. Okay, now let me recall back. So this is the Boyle's law. Let's see that Charles law, number of mole and a P, right? Number of mole and P. So hold on, number of mole and a P, that is Charles law. And then is Gay-Lussac law. Okay, Gay-Lussac law is volume and the this number of mole and the volume constant, Gay-Lussac law. Okay, and then finally Avogadro law. Avogadro law tells that these two are fixed, pressure and temperature are fixed, then volume is directly proportional to n. Yes, of course, if pressure and temperature are constant, these two are constant, these two are constant, and volume in the number means more number, more volume, right? So that's why volume is directly proportional to n, v by n equals to constant. That's the Avogadro law. So now, what is the behavior of gas at standard condition? That's a good question. Okay, but the question is, what are the standard condition? So, or that is said to be the STP, or standard temperature and pressure. So, STP means pressure, uh, um, temperature, okay, volume, number of mole. Okay, number of mole. It is okay, guys. Number, not the number of atom. Pressure is 1 atm. Temperature is 273.15 Kelvin or 0 degree centigrade temperature. Volume is equals to 22.4141 liter, and number of moles is equals to the Avogadro number, means that's the one. Avogadro number is one. So number of mole is one mole, V equals to this. So what we learn from these two is number of mole is one, and the temperature is 273.15, and pressure is one, then volume is 22.4 liter. That much volume of 1 meter gas. So that's the standard volume. Okay, and that's why standard molar volume of the ideal gas, not other gases, ideal gas is 22.4 liter. So if you have an ideal gas, its volume at standard condition, means at 0 degree centigrade, at 1 atmospheric pressure, um, and 1 mole, then its volume is 22.4 liter. So that's the standard condition. Now let's see that again here in this chapter. See, number of mole equals to 1, P 1 atm, T equal to 0 degree centigrade, V equal to 22.4. Number of gas particles, yes, 1 mole is equals to what? 6.022 times 10^23. So that, okay. So mass is, this is the helium, that's why mass will be 4.003 gram, and the density is there. Similarly, other gases also, but remember that if 1 mole means that 6.02 times 10 to the power 23 particles, okay, at the room temperature, and that is at the 0 degree centigrade or 273.15 Kelvin, the volume of the any of these gases will be 22.4 liter if they are ideal gas. However, they are not ideal, but they are very close to ideal. Okay, so now let's go to the ideal gas law. We have so far studied that we have studied the Boyle's law, we have studied the Charles law, we have studied the Gay-Lussac law, we have studied the combined law. Combined law is PV by T is equals to constant. Okay, so that we always studied that. Now the what is the ideal gas law? Ideal gas law means that gas which is followed by the ideal gas. Ideal gas means not interacting gas. It has a zero interaction with any of them. So its a volume is zero. What is the ideal gas? Ideal gas, the molar volume is equals to zero. Means 1 mole has the volume about zero, because these ideal gas particles are the point particles. That's why 1 molecule of that ideal gas, its volume is about zero, but 6.02 times 10 to the power 23 molecules, and that means that 1 mole is equals to 22.4 liter. You should remember that. Okay, so the ideal gas law tells us that product of the pressure and volume is equals to nRT. Okay, where R is the universal gas constant. The numerical value of the R depends upon its unit A, but it is generally this 0.821 atm liter per mole per Kelvin. That's the R constant, gas constant R. Okay, so and this is the ideal gas law. So ideal gas law said to be the product of the volume